Okay, welcome back from spring break. We're going to start off with some math bright and early in your first day back. So we're going to start off with some review, and then you will have a worksheet for homework, and you should have that after this lesson. So you should have in front of you your 8.4 notes. We're going to go through those right now. If you guys want to stop the video, make sure you feel free to do that throughout the video. Okay, so let's start by reviewing what the GCF is and how to factor out the GCF. I'm going to do the first two, and then I'm going to have you guys do the second two, and I'll just write the answers on the board. So when you're looking for the greatest common factor, what you're trying to find is some number or monomial that you can divide evenly into each term in the expression. So you're looking for something that can divide into 56x squared y to the fourth and into 32x squared y evenly. And you're looking for the greatest thing that can divide evenly into both of those terms. So if you look at just the 56 and the 32, you should see that 2 is a factor, and you could factor that out, but you want to make sure you're looking to find the greatest common factor. So 8 is the greatest number that you can factor out. Then if you look at your variables, you've got x squared in the first term, and you have an x squared in the second term. So you can evenly divide x squared in both of those terms. So we can factor that out. Also, if you look at the y term here, the y part, you can factor out a y evenly into both of those two terms. Okay, so once you figure out what your greatest common factor is, you're going to divide each term by the greatest common factor. So you're going to take 56x squared y to the fourth, and you're going to divide 8x squared y. When you do that, you're going to be left with 7, and x squared divided by x squared is 1, so that cancels, and then you'll have y to the third. When you divide the second term, 32x squared y by 8x squared y, you will have 4 left, and then when you divide the variables x squared y by x squared y, you just get 1. So there is the final factored form. Okay, second one, you're looking for a greatest common factor again. If you just look at the 16 and the 4, you can know that 4 will divide evenly into both of those terms. And then if you look at the variables, a, b, c will divide evenly into each of those two terms. When you divide the first term by 4a, b, c, you'll be left with 4a squared, and then bc will just cancel. So you're just left with 4a squared. When you divide the second term, 4abc by 4abc, you're left with 1. Make sure you don't forget that you are left with 1 when you have those scenarios, because a lot of you just want to write nothing there. Okay, so I'm going to write the answers to these two. You guys can stop the video, I guess, before I write. Here, stop the video now. Do the problems, and then I'll write the answers on the board. Alright, so next thing we're going to review is FOIL. Make sure that everybody remembers how to FOIL, or multiply two binomials. So the F in FOIL stands for first, the O stands for outer, the I stands for inner, and the L stands for last. Okay, really quick, I'm going to review how to FOIL here. So number 1, you're going to multiply first times first, which is 3x squared. Then you're going to multiply outer, which is 12x, inner, 1x, and then last, 4. Make sure to combine like terms. You've got 3x squared plus 13x plus 4. Okay, let's see if you guys do the second one here. You guys do this one. Stop the video right now. See if you guys can go through that on your own. And then when you're ready, I'm going to just go through it now, but you can check your work. All right, let's move on to some special cases. So we're not going to learn anything like startling at all today. We're just going to learn a couple patterns, notice a few things. So when you have some binomial, in this case a plus b, and you square it, something special happens and there's a pattern. When you have this binomial a minus b and you square it, there's a pattern to that. So let's go through and find the pattern. So a plus b squared is the same thing as a plus b times a plus b, right? It's just, this is like 4 squared is the same thing as 4 times 4, okay? So if you go through and FOIL this out, first times first, you're going to get a squared outer plus ab inner plus ab last plus b squared. Notice the two middle terms are like terms, and if you add them, you will get 2ab. And actually, every time you multiply two binomials that are the same, or you square a binomial, the middle term is always going to be double the first term times the second term, or a times b. Okay, let's see what happens when we multiply a minus b times a minus b. So we're going to FOIL this. First times first is a squared outer minus ab inner minus ab, and then last plus b squared. So you should end up with negative 2ab as your middle term, because they are like terms. You can add them. So again, here's your pattern. Your middle term is always double the product of your a and b, or your first term here and your second term there in your binomial. Okay, one more pattern that you need to be aware of when you're doing these is a problem like this. When you're going to multiply two binomials, one of them is a difference, a minus b, and one of them is a sum, a plus b. Notice what happens. First times first is a squared, outer is plus ab, inner is minus ab, and then last is plus b squared. Now notice, these two things here will cancel, and you're just left with, whoops, that should be minus b squared. And you're left with a squared minus b squared. So every time you multiply two binomials where these two numbers or variables here are the same, and these two numbers or variables here are the same, and one's a plus, one's a minus, or one's addition, one's subtraction, the pattern is you will always end up with this a squared plus b squared pattern. So let's try a few of these. So I've listed the patterns there at the top for you in the box. If you want to reference them, you can. Or you can always just FOIL things out. So let's look at the first example. You have x plus 4 quantity squared. We know that that's just x plus 4 times x plus 4. Again, we know that because 4 squared is 4 times 4. So first times first is x squared, outer plus 4x, inner plus 4x, and last plus 16. All right, so this is x squared plus 8x plus 16. Now one thing you should notice and sort of understand is that this middle term here is always double the product of the two terms in your binomial. So this is x times 4 times 2, which is 8. All right, and the first term here is always just the first term in your binomial squared, and the last term here is always the last term in your binomial squared. Okay, so if you can memorize those patterns if you want, or you can FOIL. I'm thinking most of you are just going to FOIL right now, and the pattern will make more sense later when we start to do other things. Okay, so I'm going to have you guys try the second one here on your own. So you want to stop the video, and I will go through this, and you guys can check your work. few more examples, and then you will work on your homework. Okay, this example 3 and 4 are two binomials that you're finding the product of, where one is a sum and one is a difference. And the terms, the first terms in both of your binomials are the same, and the terms in the second slot there are the same in both of your binomials. Okay, so again, just FOIL this out for now, and you'll notice the pattern that's happening every time. So first times first is x squared, x times negative 4 is negative 4x, inner is plus 4x, and then last is minus 16. So combining like terms, you're going to get the middle terms to cancel, and you'll have x squared minus 16. So every time when you have this scenario, this a minus b times a plus b scenario, you will always get the middle term to cancel. Okay, let's look at the second one here, example 4. First times first is 100, outer plus 10y, inner minus 10y, and then last minus y squared. Middle terms cancel, 100 minus y squared. Okay, one last problem. It's a word problem. What you need to do, it says, okay, the figures are squares. So these two little squares inside of each other are they're squares. Find the expression for the area of the shaded region. Write your answer in standard form. So the shaded region is just this region in here. It's basically saying don't include the area of the little white box. So what I'm going to do is I'm going to find the area of the larger square and then the area of the smaller one in here, the white one, and subtract the area of the white square from the large square. So the area of, I'm going to say the gray square because it's probably gray on your paper, minus the area of the white is going to equal the area of the shaded region. Hopefully everybody agrees with that and is on board with that. So the area of the shaded region has to equal the area of the gray square, which is x plus 7 times x plus 7, minus the area of the white, which is x minus 2 times x minus 2. So you guys have a lot of foiling to do here. So I'm going to start foiling x squared plus 7x plus 7x, or you could use your pattern. You know a pattern now. And then I'm going to FOIL in here. So this is going to be x squared minus 2x plus 4. All right, now make sure when you subtract this whole expression here, you're going to distribute that minus sign. Okay, so I'm going to go through and maybe I'm going to combine these two terms here. X squared plus 14x plus 49 minus x squared plus 2x minus 4. And I'm just going to combine like terms here. So I notice that my x squareds are going to cancel. Next thing I'm going to start combining are my x terms. So I've got 14x plus 2x is 18x. And then 49 minus 4 is 45. So there you go, area of the shaded region. Okay, sorry that was a little long. You will have the rest of the period to work on that worksheet. Don't do all the problems. The problems are written at the top, and I will check that tomorrow for completion. Have a good one.